everyone, welcome again. In this session, we will be talking about types of table in Snowflake. We will be talking about different constraints on the table, different data types, and then at the end of the session, we will be doing some demo, right? So when we talk about types of table, the tables are divided into four categories: permanent table, temporary table, transient table, and external table. Permanent tables are like any regular tables. They will consume some space. They will support all the features of Snowflake depending upon the version of Snowflake you're working on. For example, time travel and fail safes are fully supported in permanent tables. When we talk about temporary tables are part of the session, right? They will support time travel only in that session. Now the question is, what is the session, right? So in Snowflake, you have different worksheets. For example, this is your worksheet 1 and this is your worksheet 2. And let's say you created a temporary table T1 in this worksheet. The first thing is they are part of the session. It means T1 is not visible here. First thing, because we have created the T1 in first session. Now the next thing is, if we delete the T1 or if we drop T1, right? We can recover this T1 into the session using time travel feature, right? But let's say this T1 is created here, right? And we close this session. It means we close the window. So it means once we open the window again, this T1 won't be visible because this is part of the session only. I'm just explaining the very simple thing, how session works in Snowflake, right? So session works based on the worksheet. One worksheet means one session, simple. Now talking about a transient table. Transient tables are permanent tables, like permanent tables. The only difference is they do not support failsafe. It means once we delete the data, even Snowflake won't be able to recover the data. They support time travel, but they do not support failsafe. What are external tables? External tables are the tables in which data is stored somewhere else. For example, let's say this is your Azure cloud. We have some data D1 here with some 4 columns: 1, 2, 3, 4. Now what we have, how external table works? Let's say this is your Snowflake worksheet 1. What we can do, we can create an external table that will reference this data, and the only thing which will be stored in Snowflake is the metadata of the data, right? Now let's jump into more details. So now let's read some theory first of all, right? So permanent tables is like regular database table. They will consume space, time travel, fail safe period can be enabled, right? One thing which is common across all the tables by default are micro partitioned, compressed, encrypted, and stored in column format. It doesn't matter what type of tables we are creating. It means tables are micro partitioned, compressed, encrypted, and stored like column formatted in all types of table in Snowflake. Now, when we talk about temporary table is used for non-permanent and transitory data, right? This is what is important, transitory. So it means if we are creating some table just for storing temporary data, for example session specific data, ETL data, then we will go for temporary table. Temporary table only exist within a session in which they were created and persist only for the remainder of the session. As such, they are not visible to other user or other sessions. I'll show it to you when I'll do some demo, right? Once the session ends, data stored in the table is purged completely. Purged is nothing but deleted, right? Deleted completely from the system, and therefore it's not recoverable either by user or by Snowflake. You can create temporary table that has same name as an existing table in the same schema, effectively hiding the existing table. Yeah, we will do it in demo if time permits, right? Now, what a transient table? Transient tables, persist the data until we drop them. And as I have told you, transient table is equivalent to permanent table, right? With some difference that transient table does not support fail safe. So similar thing is written here. Transient table are similar to permanent table with a key difference that they do not support fail safe period. As a result, transient table are specifically designed for transitory data that needs to be maintained beyond each session, right? In contrast to temporary tables, but does not need the same level of data protection and recovery provided by the permanent table, right? So let's compare all three types of tables based on time travel retention and failsafe. So temporary table has no failsafe, transient table has no failsafe, correct? Um, and the only difference between temporary and transient is in temporary the data only lives within the session, and in transient it lives until table is explicitly dropped. Similar thing applies to permanent table, right? Until we do not drop the table, the data will always be present in the Snowflake. Now when we talk about time travel, right? So time travel is supported by all types of table in Snowflake, but obviously we need to enable it, correct? So in temporary and transient table, time travel is supported either for 0 or 1 day, default is 1, right? In permanent table, time travel can be supported from 0 till 90 days depending upon the version of Snowflake what we are using. For standard edition, it is only supported for 0 to 1 day, right? For enterprise edition and higher, it is supported for 0 to 90 days. This is important, right? Um, so now the question arises when to use transient table and when to use temporary table, right? And why there are different type of tables? What is the reason behind creating temporary, transient, and permanent tables, right? So how costing works in Snowflake, obviously on processing, but on storage as well. So what Snowflake says, see that we can do the recovery for you in two ways. First way is time travel. The second way is fail safe, right? But to do these recoveries, we need to store the data into some memory. For each, for example, for time travel, we have this memory. For failsafe, we have this memory, correct? And once you store the data for recovery, you need to pay for it, right? So it means Snowflake will charge you for time travel and fail safe in some way. So what Snowflake says, guys, if you do not need time travel or if you do not need fail safe, then you can choose table based on that. For example, you can go for transient table if you do not need fail safe option, right? So it means if there is some data which you can produce again and again, then the best practice is to go for transient table, right? For example, if you drop that table or if you delete some data, you can reproduce it again. So why do we need to go for fail safe, right? So that's the only reason. Same thing has been written here. To help manage the storage cost associated with time travel and failsafe, Snowflake provides two types of table, temporary and transient, which do not incur the same fees as standard permanent tables. Transient table can have time travel retention for either 0 or 1 day. Temporary table can also have time travel retention for 0 or 1 day. However, this retention period ends as soon as the table is dropped or the session in which the table was created ends. So this is the major difference. If somebody asks you in an interview that what's the difference between temporary and transient table, so both supports time travel, but in temporary table, time travel does not bring the table back if session ends or if table is dropped. During this retention period, right? However, this retention period ends as soon as the table is dropped. So it means, let's say there is a T1 table created in this temporary table, right? T1 is temporary table. If you drop it, you cannot recover it. if it is temporary. If it is transient, you can recover it for the retention period, for example, between 0 to 1 days, right? Uh, Transient and temporary table have no fail-safe period, I have already told you. As a result, maximum additional fee incurred for time travel and fail-safe by this type of table is limited to 1 day. It's very simple, right? By default, 1 day is your time table, right? Time table. Fail-safe is 0. So what it means that you can only pay, or Snowflake will only charge you the fee only for 1 day of storage, correct? Now, so consideration for using temporary and transit table obviously is to manage cost. Now, one more important thing: historical data in transit table cannot be recovered by Snowflake after time travel period ends. This one, right? Use transient table data only. You can replicate or reproduce images independently from Snowflake. Long-lived tables such as fact tables should always be defined as permanent to ensure they are fully protected by the fail-safe methodology, right? Short-lived tables, for example, for ETL work, for some transitory data which do not need fail-safe, we can create them as temporary or transient. We can easily migrate data from permanent table to transient table. And why do we need to do this? Just to save some cost. For example, if you have a permanent table, right, you can convert this table into transient table if you know that the data in this table can be reproduced from some source again and again, right? So why do we need to create it? It's very simple. You need to create table as select CTAS from permanent table and insert it into transient table, right? And you can delete permanent table after this is done. This is very simple, and we will do it in demo. Now, the last type of tables is external tables, right? In typical table, data is stored in a database. However, in external table, data is stored in file in external stage, and we will be talking about stage later. You can, for now, you can think external stage as some cloud, right? External tables store file level metadata about the data files such as file name, version identifier, related properties. Um, One most important thing about external tables are read only, right? And they do not support DML operation um, because they read only, right? External table can be used for query and join operation. Views can be created against external tables. So everything can be done, but we cannot update the data. Uh, Querying data stored externally to the database is likely to be slower than native database tables. However, materialized view based on external table can be created. Now, this is important, and I think most of us, and this is nothing new with Snowflake. So, what this statement is saying, you have some data stored on some cloud, right? You created a table T1 which is reading data from the cloud, and you have some table T2, right, which is reading table data from Snowflake itself here only. So which one should be faster? Obviously this one, because we are reading data from local itself, right? But what can be done to make this read faster? You can create some view, and we will be covering about views later. So what we can do, we can bring this data here one time, and then we can read this data into T1. And this type of view is called materialized view, in which we will bring the data into the storage of Snowflake, and then we will read the data from that view. And we will be covering all types of view in the next session. But this is how external tables works and how they are different from internal or permanent or transient tables, right? Now, coming to the constraints. So Snowflake provides the following constraint functionality, like it supports unique key, primary key, foreign key, and not null columns. You can create named constraint, you can create constraint on single column or multiple columns. Creation of constraints are inline or out of line. I'll explain it to you. Support for creation, modification, and delete of the constraint. For example, you can create one table and you can add the constraint later, you can delete the constraint later, or you can modify the constraint later, right? So unique key, primary key, foreign key, and not null. So these are the four constraints, right? But the most important thing in Snowflake supports, this is the most important thing in Snowflake constraints. Snowflake supports defining and maintaining constraints, but not enforcing them. And I know this is very confusing, but when I will do the practical, we will come to know. So it means you can define a table T1, right, in which let's say we have a column C1 and we say column C1 is unique, column C2 is not null, column C3 is our PK, primary key, and that's all. But what Snowflake says that, guys, I will only support, I will only enforce not null. So it means once you insert the data, for example, C1, C2, and C3, 1, 2, 3, 4, 5, 6. So what I'll do, I will make sure that C2 column cannot be not null, cannot be null, because you have defined not null here. But you can, even though C1 is unique, you can have 4 here again. I won't fail it, right? It is your responsibility. So it means these constraints are placeholder. It is user's responsibility to make sure that the constraints are enforced. I will only enforce not null constraints, and we will see it. Don't worry, right? Now, when we talk about data types are divided into 6 categories: numeric data types, string and binary data types, logical data types, date and time data types, semi-structured and geospatial. So, in numerical, we have number, decimal, int, big int, float, double, etc. String, we have varchar, char, string, text, binary. So this is normal. We have seen it in all the databases: character, string, text. So when we talk about binary, we have 2 types of data types: binary and var binary. So both are same, to be honest, right? One important data type which is very unique to Snowflake is geospatial data type. For example, when we need to store, or when we want to store any geographic location, we will be going for geospatial data. We will be covering it as well, so we'll be looking into it, right? So this is all the theory about Snowflake tables. Now let's jump to practical, right? So what we'll do, so let's, this is my first session, right? This is my first session. In this session, let's say if we want to create a permanent table. So the permanent table is like any normal table. You can create or replace table, right? Like this. You do not need to put a permanent keyword because that's not needed. By default, tables created a permanent table. So let's say, first of all, let me see if I've already created it. Let me drop it. Yeah, perfect. So now let me create this table for you guys. So I'm creating a table, orders, right? So the table ordered created successfully, this one, right? So in table orders, we have 4 columns: order ID, order date, order customer ID, and order status. So what I'm telling Snowflake that order ID is my primary key, customer ID should be unique, and order status cannot be null. So let's see how this constraints works, right? So what I'm doing now, yeah, so this is my order table. So first of all, let me select from orders first. So there's nothing into it because obviously we haven't inserted anything. We know 3 things: that order ID is my primary key, order customer ID is my unique key, and order status is not null. So let's try one thing. We know one thing about primary key cannot be repeated. In normal databases, primary key cannot be repeated. So let's see whether Snowflake supports primary key in proper way. So what we have done, we are inserting rows. This is our primary key, right? 1 2 3 1 2 3 and 1 2 3. We are repeating it again and again, right? So let's try it. So let's first see whether Snowflake supports primary key, or like it supports primary key, whether it will enforce it or not. So let me run this now. So what we can see that 12 rows has been inserted. Even though I have created a table with order ID as primary key, it is taking duplicates here, correct? So it means primary key is defined but not enforced. Now let's see unique for your order customer ID. Now what we have seen here that in fact let me do one thing. Let me do one thing. Let me put 11599 here. See, I have defined that this column needs to be unique, right? But let me try it now again. So what I can see that even though I have defined this column is unique, it's still accepting it and inserting the data. Now see the not null constraint. Now let's make this as null, right? I have defined into my table that this column cannot be null. And let's try to insert this data now. Oh, 1 second, oh, not this one, sorry, this one. So basically, let me run it again because this table is another table, that transient table, which we will do the next thing in demo. So let me run this now. So what we can see, null result in a non-nullable column. So it means Snowflake, and let me go through the theory again just to make sure you guys understand it. This statement was very important. Snowflake supports defining and maintaining constraints, but not enforce them except not null constraint, which are always enforced. So this statement has been proved now, right? Now let's talk about transient table and temporary table, right? So yeah, one more thing which I need to tell you guys that we can define constraint when we are creating the table, right? Or we can alter the table to define the constraint or on any column. So for example, alter table orders, we need to add a unique constraint on order customer ID. We can do it in this way. Now let's move to temporary table and transient table. So to create the temporary table, you just need to put a temporary keyword here. Simple, correct? Let me do one thing first. Maybe I have defined it for you guys first. Let me drop it first if it's already there. Yeah. So now let me create the temporary table. So temporary table is created here, right? Now let me see whether this table, see temporary table are the table which are only visible in one session. We know this thing. So let me copy this and let me go here and let me paste it. Now let's see. So this is my another session. So it means temporary table does not exist or not authorized. So it means we are not able to see this table here, right? So, now, so when we want to create the transient table, in the create statement, we just need to put the transient keyword here. So let's do it. So we created a transient table here, right? So transient table name is transient underscore orders. Now let's do one thing. Let's put some columns, put some data into transient table. Okay, so 12 rows has been inserted. Now let's go here and select on transient table. Okay, so what we can see that transient tables are same like permanent table. We can see them in different sessions. Even though we close the sessions, the table will be already present. We know all these things. What we are seeing here that order status is null here, right? Why? Because we haven't defined any not null constraint on any column, right? So let's do one thing. Let's alter the table transient underscore orders and alter the order status to be not null. Okay, let's try it. Oops, it got failed. Why? Because column order status contains null values, so not null constraints cannot be added. So let's do one thing. Let's truncate the table. So what I'm doing, I'm truncating the transient underscore orders, right? And now let me run it again. So again, this statement should fail, right? It was successfully executed because there was no not null constraint. Now it should okay, no, I've done wrong. So what I'll do, I'll drop the truncate the table, right? Now I will see the data here. The data should not be here in any other, right? The query produced no results. Now let me alter the transient orders. Okay, so it means order status cannot be null now. Now what we are trying to see here, we are inserting null here, so it should fail. Okay, null result in not nullable columns. So what we have proved, that if the data in table is if the data in some column is null and we try to enforce the constraint using alter statement, it will fail, right? We need to empty the table, or we need to do some tricks, to move the data somewhere or delete the data to enforce the constraint. So what we have covered in this session, the types of tables, data types, constraints, and how tables and constraints are enforced. So I think you guys enjoyed the session. Do comment, if you guys want to know something else, and if something is not clear in this video. What I'll be doing in the next session, I will be creating views. And the most important thing in Snowflake is stages, Snowpipe, SnowSQL. So we need to cover a lot of things. Stay with me, and keep watching this space. Thanks a lot. Really appreciate.